What questions have remained unanswered since the dawn of humanity and will likely stay that way for many millennia? They are as follows. Where is the edge of the universe? Is it infinite? How can we answer these questions with certainty? The most effective solution is to embark on a journey into the unknown and personally verify whether the macrocosm has boundaries. Unfortunately, modern technology only allows us to do this virtually, but we are not devoid of imagination, so let's proceed. Flights into deep space are costly and dangerous endeavors. Just to leave Earth's atmosphere and reach an altitude of about 400 kilometers, the level of the ISS requires years of preparation, not to mention the technical aspects involved. However, as Jules Verne noted, what one person can imagine, another can bring to reality. So let's assume we have an immortal crew that has undergone years of training, including stress resilience, as well as a starship capable of reaching at least the third cosmic velocity to overcome the sun's gravitational pull and leave its boundaries. The third cosmic velocity is approximately 16.6 kilometers per second. Currently, this speed is achieved by probes venturing beyond the heliosphere. The interstellar shuttle must be equipped with ion, thermonuclear, atomic, impulsive, and plasma engines, and possibly solar sails. To ensure the survival of astronauts in the harsh conditions of space radiation, protective screens and other shielding technologies must be implemented. Such a ship has not yet been built, but let's imagine that we already have everything for interstellar travel. Ideal life support systems and thermal regulation, advanced communication means, an inexhaustible energy source, and reliable armor against relic radiation. Therefore, as Yuri Gagarin said, let's go. At first, we will leave Earth, crossing the Kármán line, a conditional boundary between the Earth's atmosphere and space, located at an altitude of 100 kilometers. Then we will ascend higher and higher, constantly asking ourselves whether we will withstand this deadly journey, whether we will find the edge of the universe, or be eternally doomed to wander through unexplored dimensions and voids. In recent decades, numerous attempts have been made to leave Earth, establish a presence in its orbit, and organize missions to nearby celestial bodies, and we have made some progress in this regard. But the journey has been challenging. Recall the terrible catastrophe that occurred in 1986 with the Challenger shuttle, which included an ordinary teacher from Boston among its crew. An engineering error turned the spacecraft into a multi-ton bomb even before it left the atmosphere, and its wreckage, along with the lost crew, fell into the Atlantic Ocean. Now imagine the dangers that await humans in open space. Any unforeseen event or design flaw could lead to a complete mission failure and the inevitable death of the crew. But it is too late to regret. We have already left Earth and are heading toward the boundary of the heliosphere. Beyond the Kármán line, astronauts will feel as Earth's gravity leaves them in weightlessness, where familiar physical laws blur and lose relevance. Layers of the Earth's atmosphere gradually melt away, and the radiation background becomes harsher as we enter the Van Allen belt. This region of the magnetosphere is where high-energy charged particles, gifted to us by the sun, are held. This area, deadly for astronauts and protective for Earthlings, is located starting at 4,000 kilometers above our planet. The radiation belt ends at a height of 17,000 kilometers. The values are approximate, as the layers do not have clear boundaries. The space shuttle will relatively quickly traverse this layer and head towards the exit of the heliosphere, an imaginary sphere composed of solar wind plasma that protects our system from the dangers of outer space. Along the way, we will have a long flight of 18 million kilometers, seeing neighboring celestial bodies that were previously observed only through telescopes or by the eyes of probes, from Mars to Neptune. We will cross the asteroid belt, located between the Red Planet and Jupiter, where we will learn to maneuver virtuously. And this is just the beginning, for beyond Neptune's orbit lies a true monster, the Kuiper Belt, which is 200 times more massive and 20 times wider than the one we just traversed. But what challenge awaits the astronauts ahead? Its unsuccessful crossing could tragically end the journey. And this is the boundary of the shockwave, beyond which the solar wind loses supersonic speed and mixes with interstellar matter. Only here do astronauts begin to understand what they have agreed to, as well as realize the vastness and monstrous sizes of the universe. A system about which we know almost nothing. The solar wind entering interstellar space can be compared to releasing liquid from an ordinary syringe into a pool the size of Saturn. The temperature at the edge of the heliosphere is much higher than that on the surface of the Sun, so the shock wave will be quite powerful. But let's assume the cooling and protective systems of the ship have not failed, and the shuttle with living astronauts has crossed the boundary of this protective shell. By the way, if it weren't for the heliosphere, life on Earth would hardly have arisen due to the unshielded impact of cosmic rays. So what comes next? Absolute darkness, in which the ship will travel for about 3 centuries. Perhaps the space adventurers will encounter one of the Voyagers from the late 1970s, doomedly flying into nowhere. Further on, more and more comets will appear, as the shuttle enters the Oort cloud, a giant region located a light year from the Sun. All the belts traversed will seem like child's play compared to this abyss. Only after overcoming the Hill sphere, the outer boundary of the Oort cloud, will the astronauts technically finally leave the solar system. Maybe we should turn back? After all, it is obvious that ahead lies only darkness and horror. Even in the Oort cloud, dodging comets made of small celestial bodies, the shuttle has a certain chance of perishing at any moment. However, if the astronauts withstand this trial, they will see the sphere of our galaxy, the Milky Way, from the outside. It will seem to them that nothing could be more beautiful in the universe. But this is an illusion. Further on, things get even more interesting. Would you like us to list what phenomena along the way to the edge of the universe could kill you? Asteroids, comets, pulsars. The main antagonists in this world are black holes. Even gamma-ray bursts emitted by active neutron star cores significantly pale in comparison. At the center of the Milky Way resides such a monster. Its name is Sagittarius A. This black hole is the heart of our star cluster, consisting of 400 billion stars. Its mass is 4 million solar masses, and its size is like that of the entire solar system. What should the astronauts do if, like Matthew McConaughey in Interstellar, they are overwhelmed by curiosity and want to fly closer to the prototype of Gargantua to take a good look at it? It's better to push dangerous thoughts away and press the accelerator as hard as possible. It is by no means certain that a wormhole is hidden in the maw of the black hole. Most likely, if the ship is not destroyed by unimaginable radiation, then the extremely high temperatures will finish what has begun. What lies beyond the event horizon and what the concept of spaghettification looks like in practice cannot be predicted by anyone. And so the astronauts find themselves outside their native galaxy. Beyond the Milky Way, the spacecraft is awaited by myriads of star superclusters and individual groups. Which one will we encounter first? Of course, the Andromeda Galaxy. After all, this is our closest neighbor, with which the Milky Way will have to merge in about 4 billion years. Do you think we are flying too long? Perhaps the edge of the universe is already nearby? You couldn't be more critically mistaken. The objects being discussed are merely tiny parts of larger clusters. Both the Milky Way and Andromeda, as well as the local group of galaxies, and even the gravitational anomaly known as the Great Attractor, are components of the Laniakea supercluster, which has a diameter of about 520 million light-years. In Hawaiian, this word means immeasurable heavens. You couldn't say it more accurately. These are just our superclusters. According to estimates by astronomers, there are around 100 such large-scale structures within a billion light-years of Earth. Can you imagine what depths astronauts will have to traverse in search of the boundaries of the universe? Inside the superclusters, they will encounter hundreds of black holes, absorbing everything that falls under their influence. The explosions of supernovae, as well as great voids, from which ominous sounds occasionally reach us. All the named events, absolutely ordinary for the universe, can easily destroy not only a defenseless shuttle, but entire galaxies. What thought will simultaneously come to the minds of the astronauts at this stage? Was it worth it for all of them to get into this? Physical isolation, monotonous landscape, lack of clear orientation in space and time, psychological tension, all of this does not contribute to positivity. But especially burdensome for the astronauts will be the absence of their home planet on the horizon. The realization that they are incredibly far from home can lead not only to severe depression, but also to suicides. A grain of sand in the vast cosmos, absolute emptiness, infinity. These concepts for the stranded astronauts will lose their abstraction and acquire reality. So, is there a boundary where the universe ends? To answer this, one needs to understand what the global structure represents. We can only observe the metagalaxy, the observable universe, starting from the moment of the Big Bang. The theories we cling to are like drowning people grasping for a straw. The diameter of the metagalaxy is 93 billion light-years, but it increases by exactly 1 light-year each year. That is, the cosmological horizon is gradually moving away from us, and the universe is expanding. In terms of knowledge about the macrocosm, 21st century humans resemble the ancient inhabitants of Earth, who sincerely believe that our planet is a flat disk resting on 3 elephants and a turtle. However, quoting Yesenin, face to face, faces cannot be seen, the great is seen from a distance. But even using powerful telescopes, we are unable to comprehend the depths of the universe and see its real boundaries. What might the universe look like? Perhaps it is cyclical. And after thermal death, it is reborn through the Big Bang? Or does it consist of billions of spheres, each governed by its own physical laws? Maybe right now, we are one step away from the boundary of a parallel world that we cannot fathom? There are countless theories. Years of observations testify to this. Matter and substance are distributed relatively evenly throughout the universe. This leads to the conclusion that the macrocosm may be infinite. But what, in this case, awaits astronauts who decide to search for its boundaries? There is another side to the problem. What if the universe has the shape of a Dyson hollow ring or a closed circular labyrinth? How surprised will travelers be when they return to the starting point of their journey after thousands of light years? Such a fiasco has never occurred in the history of humanity. Lastly, let us provide a weighty argument for the existence of boundaries in the universe. If we assume that it is infinite, then this parameter applies not only to space, but also to time and the number of objects. In other words, our sky would continuously sparkle brighter than the sun from countless star choruses. But this is not the case. Currently, research is being conducted involving sound waves that might help unravel the mysteries of the edge of the universe. Additionally, after measuring the approximate distances between galaxies, astronomers have found that the macrocosm is asymmetrical. This also supports the notion of a coveted universal boundary. However, one can say for sure, if it has a shape, then there is an edge. The other question is what lies beyond it, and whether we should aspire to that. Perhaps it is best not to disturb it. If you have revolutionary ideas on the topic, please share them in the comments. Who knows, perhaps the scientific community will listen to them. Well, Earthlings, this is not the end of the video. Ahead of us are still very interesting and simply spectacular episodes. But for me to continue delighting you with all the wonders of the cosmic expanses, I need your feedback. You can express it quite simply. All you need to do is to give an electronic like to this video. After all, we simply have no other likes, and continue the phrase, I know. This way, you will let us know that we are moving in the right direction. Don't switch off. Thank you.